Chapter 8 Motion presented by E-Physics class Fatima Convent High School, myself Dipali, class 9. We are going to see today the last topic of this chapter, that is uniform circular motion. Uniform circular motion. We are familiar with these three words very clearly. Uniform, something which is following same distance in same interval of time. Circular is around a round path or a circular path, and motion we already studied in the beginning of the chapter, change in position of object with reference to time. Now, when the velocity of an object changes, we say that the object is accelerating. The change in velocity could be due to change in its magnitude or the direction of motion or both. Can you think of an example when an object does not change its magnitude of velocity but only its direction of motion? We have already understood this before, that acceleration is change in velocity, and the change in velocity could be due to its magnitude or its direction or both. Now, in this case, we are taking the change in magnitude is not there and the direction is constantly changing. We take a rectangular path, a hexagonal path, an octagonal path, and a circular path. Now let us consider an example of motion of a body along a closed path, as shown in figure 8.9a. Show the path of an athlete along a rectangular track ABCD. Let us assume that the athlete runs at a uniform speed on the straight part BC, CD and DA of the track. In order to keep himself on the track, he quickly changes his speed at the corners. How many times will the athlete have to change his direction of motion while he completes one round? It is clear that to move in a rectangular track, once he has to change his direction of motion 4 times. Now, so very clear from this example that imagine yourself moving along this rectangular path. Then, when you are moving along this path, suppose you are moving from direction A to B and B to C and C to D and D to A. Let's take this as north, south, east and west. Now what happens? When the person is moving along this path, when he reaches B, he has to change its direction and start moving towards south direction. Along with that, it will move towards the west direction and then towards the north direction. So you can see the object is changing its direction constantly, but the magnitude or the speed with which the athlete is running is constant. This shows that he changed the direction at the four corners of the rectangle. Now in case this path becomes hexagonal, then what will be the situation? Now, suppose instead of a rectangular track, the athlete is running along a hexagonal shaped path A, B, C, D, E, F, as shown in the figure. In this situation, the athlete will have to change his direction 6 times while he completes one round because hexagon has 6 corners. What if the track was not a hexagonal but a regular octagon with 8 equal sides as shown in the figure? A, B, C, D, E, F, G, H in the figure. Let us observe that as the number of sides of the track increases, the athlete has to make turns more and more often. What would happen to the shape of a track as he goes on increasing the number of sides indefinitely? If you do this, you will notice that the shape of the track approaches the shape of a circle and the length of each of the side will decrease to a point. So if the athlete moves with a velocity of constant magnitude along a circular path, the only change in his velocity is due to change in his motion. The only change in his velocity is due to the change in the direction of motion. The motion of the athlete moving along a circular path is therefore an example of an accelerated motion. We know that the circumference of the circle with radius r is given by 2 pi r. If the athlete takes t seconds to go once around the circular path of radius r, the speed v will be distance upon time, which is given as v is equal to 2 pi r upon t, because here distance s is equal to 2 pi r. When an object moves in a circular path with uniform speed, its motion is called as uniform circular motion. So did you understand what is uniform circular motion? Object moving on a circular path with uniform speed is uniform circular motion. Now let us perform an activity. Take a piece of thread and tie a small piece of stone at one end of its end. Move the stone to describe a circular path with constant speed by holding the thread at the other end as shown in the figure. Now let the stone go by releasing the thread. Can you tell the direction in which the stone moved after it is released? By repeating the activity for a few times and releasing the stone at different positions of the circular path, check whether the direction in which the stone moves remains the same or not. If you carefully note on being released, the stone moves along a straight line tangentially to the circular path. That is, it moves along the tangent of the circle. This is because once the stone is released, it continues to move along the direction it has been moving at that instance. This shows that the direction of motion changes at every point when the stone was moving along the circular path. Say, for example, if we draw this into a figure and observe, then we will get this to be the circle if the object is moving in this direction. If the object is moving in this particular direction, then we observe that at each point when it is moving, it forms a tangent line to the circle. So if I stop my motion on the circular path and come to a straight line, then the object will be moving on a tangent path this way. If I stop here, then it will move with a tangent path this way. Similarly, each time I stop the motion of the object, it will stop the motion and move in that particular direction. So these are called as tangent paths of the object. Now, when an athlete throws a hammer or a discus in a sports meet, he or she holds the hammer or the discus in his or her hand and gives it a circular motion by rotating his or her own hand. Once released in the desired direction, the hammer or discus moves in the direction in which it was moving at the time it was released, just like the piece of stone in the activity described above. There are many more familiar examples of object moving under uniform circular motion, such as motion of a moon, the earth, a satellite, in a circular orbit around the earth, a cyclist on a circular track at constant speed, and so on. So we can say that the object is moving along a circular path and it performs uniform circular motion. Here is the last topic of this chapter, and we go through the summary of this chapter. It says motion is a change of position. It can be described in terms of distance moved or the displacement. Motion of an object could be uniform or non-uniform depending on whether its velocity is constant or changing. The speed of an object is the distance covered per unit time and velocity is the displacement per unit time. The acceleration of an object is the change in velocity per unit time. Uniform and non-uniform motion of the object can be shown through the graph, and motion of an object moving at a uniform acceleration can be described with the help of following equations, namely v is equal to u plus at, s is equal to ut plus half at square, 2as is equal to v square minus u square, where u is initial velocity of the object which moves with uniform acceleration a from time t, v is its final velocity, and s is distance traveled in time t. If an object moves in a circular path with uniform speed, its motion is called as uniform circular motion. So, we end the chapter here. You will be able to answer these questions. Read the chapter thoroughly once and you will be able to answer. Next video for this chapter is going to be for numericals related to this chapter. Thank you.